Hello, my name is Samuel and I'll be presenting our submission for the Impact Hack Hackathon. In this hackathon, we designed a recommender-based device which can help in social good, especially for agricultural productivities, to increase yield and also to reduce hunger for the good and good of the community. Our project, called FarmPro, is built with social good in mind, and we aim to achieve this by building a device that can increase agricultural productivity, thereby reducing hunger and also improving the quality of life, especially for people in Africa and other parts of the world. To be able to build our solution, we need to source for locally available datasets, where we are going to be taking the NPK values of soils, which are nitrogen, phosphorus and potassium values, the pH values, the temperature and humidity under ideal condition, and also the amount of rainfall. With all this data put into good use, we're able to predict which soil, which crop is good for a particular soil. So it's not going to be manual, it's going to be taken from a device built with Raspberry Pi. With all this put together, we're able to come up with a solution which can analyze a soil sample and can predict if maize crop is good for the soil or not. The device can be handheld by the farmer without the farmer going through the stress of hiring soil analyst or agricultural extensions to perform soil analysis. With just a piece of device in their hands, they can be able to carry out soil analysis on their own and make predictions that can improve the yield. During the work on this project, we were able to see and also learn more about the factors affecting our agricultural productivity, and we also conclude that it's all about proportionality of nutrients. If nitrogen is lacking, but with phosphorus, potassium, pH, humidity and temperature in the right proportion, we can still have high productivity. So that's the major insight we were able to draw while working on this project. So here I have our farmland where I'm going to be taking the sample. So this land is being prepared for cultivation, and very soon planting will start on. So I'm to decide whether it would be good to have a maize plant on this farmland or not. So I'm going to be fetching a soil sample and I'm going to be running my artificial intelligence, my soil analysis using the device I built to test if this land is fit for maize plantation or not. And here I have my demo. This is my Raspberry Pi and this is the moisture sensor along with the temperature and humidity sensor. So it's going to test majorly, it's going to be taking input from both the moisture sensor and the temperature sensor to check for the water level, the amount of rainfall, and also for the temperature and humidity of the soil sample. So on real time, using machine learning and artificial intelligence, the Raspberry Pi is going to process the data in real time and recommend if maize is good for the soil or not, since maize is commonly found mostly in African farms. So I'm going to demonstrate the sample output now. So this is the display interface of my device, which is the Raspberry Pi window. So I have the code written here. So to go over the code, I'm going to open this. And here I've integrated Raspberry Pi to work with temperature sensor, moisture sensor to output my prediction whether the soil is good for maize plantation or not. So to run the code, I simply come to the terminal and type in Python 3 impacthack.py. So it's going to construct a graph of my data, which is what I have here. So here I have my predictions. So I have my temperature and humidity at ideal conditions. And if I check, my crop prediction is saying 1, which symbolizes maize is okay. So with this, I have my prediction on the soil sample which I fetched from the farmland. So my analysis from my analysis, I'm having that it's good to plant maize on this farmland. So I should be expecting a high yield of harvest this year.